So today we'll be continuing complex numbers. Today we'll be learning about Argand plane. So in our real axis or real system, we used to have something like this system. So this was x-axis, this was y-axis. So any point, suppose P, so the distance from here, this was known as abscissa, and this distance right here, this was known as ordinate. So this y distance was the x distance, abscissa and ordinate. But in complex plane, so the coordinate plane that represents the complex numbers are known as Argand plane, or it is also known as complex plane. So here we have something different. So we will be having some like the same axis will be written. So we will consider this as capital X, and this will be what, capital Y, X dash, Y dash, and suppose we have the complex numbers. So this here is the known as the real axis, and these are known as imaginary axis. Okay, so now suppose if you want to denote a complex number like 3 minus 2i, so for that we need to travel 3 distance here. So 3 and negative of 2i, suppose 1 2 3 and 1 2, so this will be what, 3 minus 2i. So this is how you represent here. Suppose the point A, suppose you have another complex number, what, 2 plus 3i, so 1 2 3 1 2 here. Suppose the point E, so 2 plus 3i, and so on. If you have like minus 2 only, so this will be what, 1 2, so you represent here, so C, that is equals to minus 2 plus 0 I. So this is how you represent complex numbers on Argand plane. Suppose if a point like P of X represents the complex number, that is Z equals to X plus IY, then the distance between the P and the origin, suppose this is our origin O, that will be given as, so the distance will be given as square root of x square plus y square, that is also known as modulus of Z. So this will give the distance between like a point P here and distance from the origin. Now we'll see some more things related to Argand plane. Suppose we have a Argand plane like this, and this is our origin right here, this is x and this is y, and suppose we need to find the geometric interpretation. If z is equals to x plus iy, so z bar will be what, x minus iy. So let us see how the points will be represented as. Suppose if our what, z is like this and we consider p as z, so if we have any arbitrary like complex number, it will be having like this form, and if you want negative of p, that is equals to minus x minus iy, we'll just do the mirror image of it. It will be here, that will be negative p, so that will be negative z. Now if you want to have like the conjugate, that will be what, like here something like this, because our x is positive and our y is negative, so suppose conjugate is something like this. And if you have something like minus x and plus iy, so this will be what, suppose anything, so this will be right here, suppose we consider as q bar. So these are some geometric interpretation or representation for it. So thanks for watching it.